Let's start with the library method, and we'll take a look at the first, peak detection. Here we are looking at the library method, the tab peak detection. So zooming in, we can take a quicker look at the choices. Number one, TIC analysis, meaning total ion chromatogram analysis. You integrate the peaks, all the ions are summed up. Deconvolution, which is a unit mass, and then Schur mass. Let's take a look in detail. Let's take a closer look at the ability to define the TIC signal. So there are a lot of different kinds of signal types. In this case, I've simply got scan. But I potentially could have SIM-scan, and I might want to extract out and integrate the signals originating from the SIM or the scan. On accurate mass, it might be something like scan and product ion scan. I can slice off the signal type that I want. Alright, we have used TIC on mass spec signals. As you see here, I've found through library matching components and library spectral match. But what about 2D signals? Well, in this shipping batch, there's a TOF plus a 2D signal. So let's go to the method. And if I look at this method and I look at the TIC part and the signals, I can assign not a mass spec but a 2D signal. So the DAD signal is here, and I can assign that and apply that to all of the samples. And let's run that here. We don't have any spectral information, so we're not going to need those. But what I do have is I have the results that where it did find the components here. For example, that large component right there is highlighted. And if I had a library that didn't have spectra but just had retention time, or better yet, retention indices, I could use that library and do matching of these component peaks against retention indices, let's say. Alright, let's take a look at the peak filter section. I can see I can exclude masses like 28 nitrogen. I could add to that list. A lot of times I'm not interested in these low molecular weight masses, so I can just exclude them. The signal to noise threshold, very useful if I'm not interested in those low-lying peaks. I can just threshold them out. Another useful thresholding game is maximum number of peaks. You can see I can rank them, so I can put the peaks that have the highest area or height first, and then filter by maximum number of peaks. So if I know I've only got 10 big peaks, I can say only show me the first 15 ranked by area, and I should cut out all the other peaks. Also, a set of area filters. So I can filter by the number of counts. Again, eliminating small peaks, the integrator can show me a lot of peaks. I can do a relative area, percent of the largest peak. The height filters, again, very useful either by absolute or relative height. I can remove the noisy peaks I'm not interested in. Thanks for your attention.